Did you know that Google personalizes many searches by city, and Also Asked is the only tool to access live People Also Asked data at city level? Try for free at alsoasked.com.
Tired of SEO guesswork? Quadra's AI agent goes deeper to uncover high-impact optimizations and completes hours of SEO in minutes. Get started now.
I was going to say that SEO with Fat Joe is as peaceful as this, but then the birds are all having fights.
Thank you, Lila. Nice to meet you, everyone. So yes, I'm Guillaume, the CTO of Babar. Babar with two B's, not the elephant, sorry. Babar was the temple of Shamash, the Sumerian god of justice, which was worshipped in Sumerian times. And we wanted to do something to do justice to the good website, to the good web pages, and to the good web links. That's why we chose this name. At Babar, we crawl the web a lot. So the first question I'm going to answer is, why do we do that? What do we do with the data we crawl, and how do we sell this data to our customers? I'm going to explain a little bit of technical details. I'm the CTO, so a lot of details in the technique. How do we crawl the web in such a large scale? How much do we crawl? A bit of gloating about the bigly beautiful numbers. Pretty impressive, I hope. And finally, why do you crawl my website? That part is about the taste that it is to crawl the web at large, to crawl websites, web servers that have never asked for that. And sometimes people complain, so I'm going to do a bit of an apology. And also, since we're French, I'm going to complain with some stuff on the web, explain to you what it's like to crawl some websites which are particularly nasty. Let's start with, why do we crawl? So what is Babar? Actually, the story of Babar started with two companies, mine, specialized in big data, machine learning, stuff like that, and the Peronese brothers company, X Labs, nothing to do with Elon Musk, prefer to make it clear. So at X Labs, they had a tool called yourtext.guru, and we, 4 years ago, we started Babar, and we joined our forces with both yourtext.guru and the Babar technology itself. yourtext.guru helps you to create content that Google will consider for a keyword. Who knows what is QBST? Whoa, really? Query-based salient terms? Nobody? Okay, yeah, thank you. So that was Pierre, the tall guy, the SEO guy in the room for Babar. So we give you basically the terms that you have to put into your content so that Google will consider your content for a given keyword. There are a lot of other things in yourtext.guru now, keyword research, monitoring, link strength prediction, stuff like that. And the other tool is Babar.tech, in which we serve the data from the web. So a lot of information about backlinks, about the semantic, about your competitors, many things that you can find about the web, about the graph of the web. So why do we crawl? The first reason is to store and serve the World Wide Web graph to our customers. So give information, raw information about the number of backlinks, the number of referring domains, referring hosts, referring IP addresses, a lot of raw data that we can give to our customers, information which is mostly used by experts. And by the way, Babar is both a UI and an API. A lot of our customers actually use it as an API to power their own tools. we analyze the content. It's very important because a lot of the things that Google and other search engines consider is about the semantic, is about the content. And we have actually in our crawler a lot of analysis which is performed on the text. We cover something like a dozen languages. We use this information to help predict the value of a link between one page and another. We use this to have a semantic orientation of the websites, which helps to find your competition. And we do the QBST reverse engineering with this information. QBST is the way Google has to generalize user feedback in the SERPs. When you search for a keyword and you click on a link, obviously the information about this particular URL, this particular page, is used by Google to boost this page for this keyword. But it's really specific, it's not generalized. And to generalize, Google takes the important terms in these pages that have been clicked and put them back into the information linked to the keyword. So a keyword is actually accompanied by a list of terms which are used by Google to pre-select the contents that can rank for a given keyword. So QBST was actually something that many people were believing exists, but it was actually shown last year, I think, with the Google leaks that they actually have this algorithm. And finally, we compute a lot of graph metrics. So think about PageRank, except that we have the semantic PageRank, which is maybe more known as topical PageRank. We have also anti-spam metrics, which helps to give a really relevant score for websites and web pages. And basically, we have many metrics that can be used for a ranking system, which can help you to measure how a website or a web page can be interesting. And now, how do we crawl? So the history of the crawler started maybe in 2015. As I told you, I used to work on machine learning, big data, and we were doing a large language model before it was, not before it was cool. It was already cool, but it didn't work like it does today. So we were looking for a lot of data to train our own models. Of course, I didn't create OpenAI, so you can guess that it didn't work the way I hoped. But we were using Common Crawl. Common Crawl is still used today. It's a data set which is produced every month on a crawl of the web, and it's given freely by an organization to everyone. We quickly realized that the value, the quality of the data in Common Crawl was very low, so we started crawling ourselves using an open source software which is called Bubbing. It's made by, it's basically deprecated now. It was made by the University of Milano, so academics working to crawl the web and analyze the web for science. It was full of bugs, a lot of problems, and basically it could only crawl once and then it stopped. And it was very quickly falling into the black holes you can find in the web. So we quickly realized that we will have to do our own index and use this index to decide what to crawl and what not to crawl. We designed a distributed graph database using also message queuing to communicate between the various servers. So that's the technical part. We have on the left the brain of the crawler, which is basically the database of all the URLs, all the pages we have fetched on the web. And on the right, you have the fetcher itself, which is a modified version of Bubbing, very simplified. We just kept the best part of bubbing and removed everything that was linked to processing the list of known URLs. We have two different parts of data processing. One which reacts in real time, basically. When we call something, we take it and we store it. We process some stuff, specifically the content. And one which is more asynchronous, which is used to compute the metrics and to decide if we will crawl a page or not. So that gives that kind of schema. You have the iterator, which processes all the URLs and computes the aggregated metrics and decides if we will crawl a page or not. It took a lot of work to do what we are going to show you after that, to perform the kind of crawling speed that we achieved. It took a lot of effort and a lot of specific designs. We worked on in-memory compression for the URLs because we process a lot of URLs. We have the URLs in the links, in the pages, everywhere. So compressing them in memory from the beginning of the crawl to the end, except of course when we have to crawl the page itself, helped us to manage a lot of data. We also have a compression for the semantic embeddings. I don't know if anyone knows about the embeddings, but it's basically a list of numbers that we use to represent the semantic of a page. And we have also a DB level, low-level compression in RocksDB, which is the low-level database that we use behind the hood. How much do we crawl? So big numbers now. First, Cloudflare has a leaderboard of bots, verified bots, so nice bot that follows the robots.txt instructions. We are currently number 5 in the SEO crawler category. We were at some point just after the Ahref bot, and sometimes we are lower on the scale. It depends on the day, on the week. What's important is that we crawl 3 billion pages per day. 3 billion pages, which are basically split like that. The green ones here, so something like 27,000 per second, are actually 200 answers, HTTP answers. 200, it's we have the content. The rest is redirections, errors, and timeouts, stuff like that. The white line here is the number of pages that we can process the content on. So something like 15,000 pages per second that we analyze the content of, and we create a representation for the graph and for the computation of metrics. This is the number of URLs we know. 1,500 billion URLs in the database. That's the number of pages we have stored, not completely. We don't keep all the information. We just keep a small embedding representing the semantic orientation. But we have to store all the links. And we managed to do that with just this small infrastructure. It's small compared to our competitors anyway. We have 60 servers for the database itself. We have 12 servers for the messaging. So we send messages between the different parts of the infrastructure. And 6 only for the fetching itself. So the crawlers themselves are only 6 servers. We use more than 200 terabytes of data, but it's very small actually for this kind of size. And now I think I have to say something. Additionally, maybe it will give you an idea. So every second we crawl 40,000 pages on the net. And the cost for this crawling is about 500 euros per day. So maybe it doesn't give you any idea, but it's very low compared to the competition that we can actually know of. And now, so the experience part, an apology and a bit of complaints. We are French, after all, grumpy French. Why the hell are you crawling my website? That's one of the emails I received at the beginning of our crawling. And a poor student had been crawled repeatedly by my crawler. I'm sorry for him. He had an app on Heroku. I don't know if you know that. And basically it's instances that are started on demand. And my crawler was trying to get its robots.txt. It didn't even have a robots.txt, but each time I was trying to crawl it, the instance started. It was costing him money, and my crawler anyway couldn't get it because it was timeouting. So sometimes, maybe once or twice a month, we have emails from people that complain about the crawling. And we really try to be good citizens. It's really important now, especially with the AI crawlers, which are coming really badly on a lot of servers. It's important from the both my position as a crawler and the position of people who have web servers to understand what's happening. When a robot wants to get your content, it doesn't want to have JavaScript, it doesn't want to have a lot of things that the users, your human users want. They just want static information. If you can give them very quickly, it's good for them. Unfortunately, a lot of people are doing their websites only for the users, and that's where something is not right. And sometimes we provoke some problems on these websites, and we're sorry for that. We try not to, but it's not very easy. SEO is hard, but doing a search engine is even harder. So we are polite. We try not to crawl too much on a given website or on a given IP address. We respect the robots.txt. We respect even directives like the crawl delay. We respect the HTTP 429 code. You all know what it is? No, it means just slow down. And well, if you don't want us to crawl your website, obviously no problem. Add our crawler, it's Bark crawler, B-A-R-K, or, well, anyway, you can find it on our website. Put this on the robots.txt and we will stop crawling. Don't make a rule on your firewall that drops the connection because it makes us timeout and it's bad. It's really bad. It's just lost CPU time. And HT access is not a great idea because we don't know why we are getting errors. Just put us on your robots.txt. It's the really most simple way to do it. Now, two things to finish the talk. One, which is quite normal. There are great websites on the web, Facebook, Twitter, and so on. And they are a pain to crawl because, not to crawl, we don't crawl them actually. Most of them ban the robots, but they are a pain to deal with because they have a lot of backlinks going to them. As I told you, we have a distributed system, so we have split the internet into small chunks, not that small, but into smaller chunks. And when a website, when Facebook is on one of these partitions, we call them partitions, the partition tends to grow so much that it doesn't, it cannot stay on one disk. So it causes a lot of problems. We had to deal with that with various solutions, but we still want information about the backlinks, but not all the information, so we have to treat them very specifically. And to finish, a very nasty problem that we always have, I call them Schumnigerats websites, or domains actually, because they have millions and millions of subdomains. and they tend to hog the crawler. They are basically black holes. They generate new hosts on demand, so you can always find. They are basically infinite websites. So if you crawl them, you will end up only crawling these websites. So obviously we have a lot of different solutions to remove them from our crawl list, but sometimes we still fall for them, and it's a real pain. Obviously, if they exist, probably some search engine still use their, I would say that, their information to boost the target. If they exist, they cheat, but they exist, so that's a thing. And this is the end. Thank you very much. Thank you, Lila. Thank you, Julie. And thank you to the brightonSEO staff. That was great.
Demand sphere. Limitless visual insights from the SERPs. Unlimited dashboards and users. Easy to use and easy to scale your growth to new levels.
Monthly reporting making you want to shove sharp things up your nose? Try Dragon Metrics, the all-in-one SEO software with mind-blowing reporting tools.